Hi viewers, hope all of you are well out there. Once again, Dave from Western Pennsylvania, USA, and I will be a chemistry professor emeritus in August of this year after over 40 years with my university. What I'm showing you here is part of my research which will continue after my retirement from teaching. And this is a small section of a graphite felt which has been lightly nickel plated. Now, if you go to one of our earlier YouTube videos, which was focusing on testing such material in water electrolysis, you'll find that somewhere back in February or March, where we define what we mean by light nickel plating. In other words, we take a section of clean felt and we put it in a nickel acetate plating bath at low voltage, very low current for 15-20 minutes, because we don't want to lose the flexibility of the graphite felt, but we want to boost the conductivity. Well, in any event, this is a small section of it for demonstration. By brush, I've applied a composite of very finely ground activated carbon, incidentally a gift from Graphite, Asbury Graphite Company, and that's over in eastern Pennsylvania. They're very generous in their support of us over the years. But it's a composite which is a binder CMC, carboxymethylcellulose, enough water to make, not a soup, takes a little while to work, but the consistency maybe of yogurt, a little thicker. And you can see this white mineral, and this is Halloysite clay. And this has very peculiar properties. Now, the typical samples from the United States, Western United States, are often yellow because they will contain concentrations of iron salts. Now, note the white coloration. And this is a gift from one of our supporters, and that's Allied Minerals Incorporated out in Utah. And in their quarry, they have some of the finest quality halloysite you can find in the world. This could be used to make china. And it does not have the yellow coloration. We're interested in this because it's peculiar. It's a clay with nano-tubular properties. And we are working on developing graphite composite electrodes for supercapacitors. We'll be uploading some of that work early this fall. We have a new scanning electron microscope. And for reasons that I don't want to disclose now, but I will, I have a composite here of activated graphite with carboxymethylcellulose binder with water and the halloysite. Now, I did not sieve the halloysite. I'm simply preparing this for demonstration purposes, but we sieved that, and of course we grind up activated carbon, and we use very fine material, particle size. So I make a paste of that, and by brush apply it to a section of this graphite felt, which is lightly nickel plated. And we want to begin to study systematically the properties of this peculiar clay with nanotubular structure. So we will begin now to test WISE electrolytes, water and salt electrolytes. Here's the typical one, ammonium acetate. This is potassium acetate. Now this is another story, but these WISE electrolytes can have very high electrochemical potential windows. Water electrolyzes at 1.23 volts, maybe 1.3 with overpotential. And some of these WISE materials have been demonstrated to have electrochemical potentials above 3.0 volts. Now, energy is equal to 1/2 the capacitance of a supercap times the square of voltage. So you can see why we would want to boost voltage. And for a set mass of a supercap, we're thus increasing the energy density. Now, supercaps are associated with power density and batteries with energy density. But there are applications, you see, for supercaps exhibiting unusually high energy densities. If you go to ResearchGate, you will find I've uploaded about 8 or 10 preprints to ResearchGate, and you can begin to see some of these papers, such as applications in spacecraft, guided missile technology, sensors, other things. But anyway, you can see a couple of clips for current collectors, right from Walmart in the craft section. And both sides have been painted by brush. I'll let this dry to constant mass. And we will begin to study the properties of these Halloysite activated carbon composites. One of my students, senior actually, undergrad senior, she's had a paper accepted to make a presentation at the American Chemical Society biannual meeting in Washington, D.C. this August. She'll be disclosing some of our work there. And I'll keep you guys posted, because many people want to do this type of work at home, or maybe you're an undergrad and you want to get involved in energy storage. And this is an excellent field to get in. So we'll let this dry, and then I will begin to explore the properties of it. And of course, with the scanning electron microscope, that's almost indispensable. So I can begin to look at the surface at high magnification before and after cycles of charge-discharge. Coulombic efficiencies, that's what we focus on right now. Milliamp hour ratios with charge and discharge over minimum 500 cycles. Anyway, we'll keep it posted, and we'll let you know the good and bad with our research as we progress. Thank you as always for watching. Bye for now.